Today's lesson, if you remember how to find area of a circle and circumference of a circle, we're just adding on one little piece. So it's really not a big deal. It's pretty straightforward. We do have a new term, and that is a sector of a circle. A sector of a circle is bounded by an arc and two radii. It's like a piece of pizza, okay? You've got these two radii and you've got this arc out here. This is a sector. So quick question, if the measure of the sector's arc or central angle is 120, what fraction of the circle do we have?
1/3.
We have 1/3, that's exactly right. Because 120 out of 360 is equal to 1/3. So if I knew the area of the whole circle, if this central angle was 120, I could just take 1/3 of the area of the whole circle and I would have the area of the sector. So in general, the area of a sector with an arc or central angle, measure m and radius r, is given by this formula. Area is equal to m over 360 times pi r squared. The m over 360 is the fraction of the circle. And the pi r squared is the area of the circle. So if you have half the circle, you would take half the area. If you have 2/3 of the circle, you would take 2/3 of the area. All right, so let's take a look at this one. Find the area of the sector. So the area is just m over 360 times pi times the radius squared. That's what fraction of the circle do we have times the area of the whole circle. And I know I'm going to be using pi r squared because it says area. And the area of a circle formula is pi r squared. So this is going to be 70 over 360 times pi times 12 squared. Sometimes these come out to be really nice numbers. Sometimes they don't. You can always check by putting in everything except for the pi. So 70 divided by 360 times 12 squared. And if it comes out to be something nice like this one is, great. It's just 28 pi. And the units were centimeters, so that's square centimeters. They will not always come out to be that nice. Do not give some horrible decimal approximation. I'll show you how to simplify one on our next example. So, here in this next example, we want to find the area of this little piece out here. It's called a segment of a circle. It's not super important that you remember that term, but it's basically the area is going to be equal to the area of the sector minus the area of the triangle, always in a problem like this. So we've got the sector is the whole pie-shaped piece, and then we're going to subtract away the triangle, and we'll be left with this little sliver that's out here. So for the area of the sector, it's m over 360 times pi times the radius squared. Minus the area of a triangle is 1/2 base times height. For the sector, the measure of the central angle is 60 over 360 times pi times 14 squared minus, in order to find the area of a triangle, we need to know the base and the height. What we're going to do is realize that all radii are congruent, so this is 14 also. That means that that's an isosceles triangle. And you can spin your picture around or you can redraw it. I'm going to redraw it over here because I can't spin my picture around. That means that this was 14, this is 14, this angle is 60. If I drop in an altitude, since that's an isosceles triangle, it's going to split this in half. So that each of these is 30. Remember that the hypotenuse is twice the short leg. So the short leg is going to be half that, is 7. So this part will also be 7. And then the long leg is the short leg times the square root of 3. So that's going to be 7 square roots of 3. So the area of that triangle will be 1/2. The whole base is 14 times the height is 7 square roots of 3. If we try to put this 60 over 360 times 14 squared, I'm just going to show you that it doesn't come out very nicely. 60 divided by 360 times 14 squared. Pretty awful. So what I'm going to do is I'm actually going to reduce this. 60 into 360 is 1/6. $14 squared is 196. Let's see, half times 14 is 7, and 7 times 7 is 49. The 196 and the 6 are both evenly divisible by 2. So I'm going to do that to simplify this. This is 98, and this is 3. So the exact answer is 98 pi over 3 minus 49 square roots of 3 square inches. On the assignment that you have out of the book tonight, it asks you to give that like to the nearest tenth or the nearest hundredth. But on quizzes and tests, I'm going to ask you to give me the exact answer like this. So you can't just put it all into a calculator. I want you to be able to simplify your answer. Yes? I'm not following you. So I've reduced the 60 over 360 and I squared the 14. I could have written 196 pi over 3, but then I just went ahead and reduced that also. Okay? All right, let's go on to the back. So the other part we have is actually a little more straightforward than that because there are no secondary problems to do. It's just arc length. The length of an arc is the distance on the circle from one endpoint to the other. It's part of the circumference. It's not the whole circumference, it's just a piece of it. So let me point out that the length of arc RS is not the same as the measure of RS. They are never the same. The measure is whatever the measure of the central angle is. The length is, if I was to cut it and straighten it out, how long is that when you put it on a ruler or something? So arc length is given by the formula. Arc length, AL, is m over 360 times 2 pi r. Where did that come from? What's 2 pi r? Circumference. So we're still doing what fraction of the circle do we have, but this time we're multiplying times the circumference instead of by the area. So here it says find the length of arc JB. By the way, they didn't ask this, but I am. What's the measure of arc JB? Well, this doesn't bode well for your quiz. Yeah, it's 100 degrees. The measure of an arc is equal to the measure of its central angle. So the arc length is going to be m over 360 times 2 times pi times the radius. So it's 100 over 360 times 2 times pi times 18. Let's see, if I divide both those by 10, that would be 10 over 36 times 2 times 18 is 36. Oh, that's going to come out really nicely, because 36 goes into 36 once. So this is 10 pi inches. Any questions about that? So the measure of an arc and the length of an arc, not the same thing at all. Two entirely different ideas. Pardon? I'm sorry? No, it's a length, not an area. Good question, though. Anything else? Okay, then let's